Now let's proceed to the next part of IBP, which is the special cases of IBP. So this is the first example of the special cases of IBP. Let us see what is special about this question here. So originally this is integrate of e to the power of x cos x dx. This is your question. So you can see that this is two functions multiplied to each other. So for sure you should use IBP. So let us see, e to the power of x here is exponential, cos x here is trigo. So between e and t comes first. So we should put our cos x here as u, and the rest of the function here should be dv. So let's write that, let u as equal to cos x, while your dv is e to the power of x of dx. So now from your u, let's further differentiate. Du over dx is, so differentiate cos is negative sine x. Therefore, du is equal to negative sine x dx. Now let's proceed with this one here. dv is equal to e to the power of x of dx. Let us integrate this one here. So integrate dv is v. Integrate e to the power of x dx is just e to the power of x. So now we are finished with that. Let's focus to open up our formula. So this is the question. So let's open up IBP. uv minus integrate v du. So let's do this. U cos x, v e to the power of x minus integrate v du. So minus integrate v e to the power of x du, which is negative sine x dx. So the first part is already settled. So let's bring e to the power of x here to the front, and then now let's focus on here to integrate. So negative times negative is just positive, so let's focus to integrate e to the power of x sine x dx. So do you see that this is again integrate of two functions? So we need to do IBP again. So let's do this. So your e here is exponential. Your sine here is trigo. So between both of them, t will come first. So sine x should be your u. Others here should be your dv. So let's do that. Let u as equal to sine x. Let your dv equal to e to the power of x of dx. Okay, so let's do this. Differentiate u, du over dx is just, differentiate sine is cos, and then du is just cos x dx. How about this one? dv is equal to e to the power of x dx. So integrate both sides. dv is v. Integrate ex dx. This is just e to the power of x. So when you have finished opening up all of this here, let's follow the formula for integration. So the first part here is already settled. Let's just cut and paste. So now let's focus to open up the second IBP for this one. So let's do this. U sine x, v e to the power of x minus integrate v du minus integrate v ex du cos x dx. So now we have settled opening up the second IBP. This is it. We have settled this, okay? So next, do you see that again you have another IBP here? And do you realize that this is the same? This is IM and this is also IM. Okay, so since this is the same, I can bring this here to our left hand side. So this will become IM plus IM because this is minus. So if you bring it to the other side, this will become plus. So IM plus IM should be 2IM. Okay, I hope this is clear for you. So now you have 2IM equal to all of this function here, just copy and paste it here. Okay, so finally we want this one. This is our question originally. So what should we do is you just get rid of this 2, just divide it to the other side. Therefore, integrate e to the power of x cos x dx is equal to 1 over 2. And then from here, I hope you can see that this is a common term, so just take it out. So in your bracket here is just cos x plus sine x, and don't forget to write plus c. Therefore, this is your final answer. So why is this within the category of special cases? I hope you realize this now, because along the way when you want to open up the IBP, you'll get the question itself back. So we just bring it to the left hand side and combine it together, and finally we can find what the question wants by just dividing 2 to the other side. So this is your final answer for example 1 for special cases question.